Yes, sir. Yes. Good evening, all. My name is Sachin Kumar, and I am very passionate about learning the ROS. And for that, I have learned some big concept about Linux as well as Python. So it is my first presentation of the Linux for ROS. Okay, so I'm going to connect my robot, which is already connected. Okay, so as you can see my screen, so first of all, I'll do a little bit short. Uh, yeah, so I will first. This is the terminal. Okay, so over this I will source the robot interface. So
Mm-hmm.
this command I already have. So for real connections source, I have to source these two commands, which is already given on the construct learning modules, which is this notebook.
Mm-hmm.
Okay, so I'm going to paste it. Yeah, so I will minimize it a little bit.
Okay.
Now
So
the second one, what I need to, yes,
can you explain to me why you need this script to be running?
yes, like if we want to uh, communicate with the robot, so we have to solve these files. These files is like calling to the actual real robots with our this IDE.
I'm not sure I understood what you mean there. So you need that to connect to the robot?
Yes,
Okay, but you're already connected right now, unless you're speaking about a different script.
yeah.
Okay, let's go on for now. We can come back to this a little bit later, okay?
Yes. So now I have to uh, open the directory.
Mm-hmm.
So cd rows to workspace, then src space, sorry, this Linux, then Linux project. Okay, I will enter, then I have to run the interface uh, script,
Mm-hmm.
which is robot dot interface dot file. Yeah, so it will take a little time to getting ready.
Okay.
So 5 seconds. So now it is ready. So in another terminals, I'll again open the another terminal which is opening there. So now I will open the same rows to workspace. SRC 6, yeah. And then I will run the obstacle avoidance
Mm-hmm.
basic script. Yeah. So as of now, it will it will get the data from the sensors, front sensors, and left side, right side.
Mm.
So all sensors, it will get the data, and according to that data, turn. It will turn and it will start moving. So right now it is checking what is in front of the robot.
Mm-hmm.
Yeah. So this is like a front range and uh, front range and the where robot is turning. So it is turning in the right side. So it will displaying over the terminal. Yeah.
Right now, it's stuck because none of the ranges are giving any values that are. Let's see if it can get out of that zone.
Okay.
Have you encountered this before? Or how will you solve this issue if we're going to fix it now?
Yeah, sir. Yeah. So how I did, decrease the threshold, threshold values also I checked in obstacle avoidance program.
Mm.
So there it is threshold value. I changed it multiple times, like point 1, point 2, point 3. Gradually, I increased so
Mm.
that robot have enough space to move.
So,
Yeah,
so,
and
so, okay, so your threshold is relatively high, right? What do you think is the effect of that? Right now, what
yeah.
can you observe
So
about that?
uh, okay, so I have to decrease. I think this because in
Why?
simulations and earlier also it was working. It was working, sir.
Yeah.
Uh,
So, okay.
might be this is close to the robot.
Yes.
Walls are very close to the robot,
Hmm.
so like it is point 0.5 meters, so I have to uh, decrease this. I will try to decrease it, and we'll see whether robot move forward,
Mm.
because right now I think robot is only rotating.
So, can you explain to me before you make that change? Can you explain to me how decreasing the threshold will help?
So
Sachin, can you hear me?
yeah, yes, sir, yes, I can
Yes.
hear you.
Uh, so, my question was, can you explain to me how decreasing your threshold will help in this situation?
Because threshold is the distance between the obstacle and the robot. So, you have to experience. But right now, I don't know how far the obstacle is, because robot is like road not here. It is in another location. So. I don't have idea. So gradually I have to decrease or increase using the cameras or the how robot is reacting over this threshold. Yeah.
Okay. So, given that hunch for you, so you opting to decrease. Okay, let's decrease it and then let's see if it works.
Also, yeah. Right now it is moving.
Mm.
Oh, so I need to. I think I did it.
So, okay, so now that it worked, right? Can you
Yeah.
explain to me
Yeah.
why it worked or how did you solve the issue? Can you explain what happened to have it working?
Okay. Yes. This threshold is like a safe distance between the robot and the obstacle.
Okay, all right. So
Hello.
let's
Yeah.
go on.
Yeah.
I understand you have got some slides that you want to present. So let's give your robot a little bit um, given this threshold that we're using of point 0.3, right? By the way, this is the one you're supposed to use. Point 0.5, it's a bit too much. I'm not quite sure where that came from, but I would want to hear your
Okay.
best as we explain in the coming slides. But let's see if the robot is managing to avoid obstacles. So you can switch to stream window now, the camera stream window. What's going on there?
The speed I need to decrease the linear value what I have given. So that also I need to uh, change.
Yeah, okay, so there are a number of things that we need to speak about. So for now, I recommend that you stop execution and let's go over your slides so you can explain to us what you did, how you did it, and then we'll review your code. Okay?
Yes, sir. First of all, thank you for the construct teams which have given the opportunity to represent this Linux for robotics.
Mm-hmm.
And so today focus is Linux and base script, how we can use the base script to control our robot. So what is our objective is applying basic commands, uh, Linux commands on ROS robotics. Okay, so I have used some base scripting to control the robot, which you have seen earlier. So the ROS interface also I go through and learn how the Linux can help you to build the script as well as how you can control the robot. Okay, so I learn how simulation as well, how you can use how can you can uh, use your base script to simulate the robot uh, in virtual world as well as in the real world. Yes. So actually, I learned the terminals, multiple terminals, how you can use for like running your scripting and file system navigations, how you can use and the management of the process, the workflow, and the roles script.
Mm, okay.
And these are the key next points which I will actually I got from the construct team only this PDF file. So this is very useful for me to remind each and every commands which I because if you are learning the Linux from the definitely is going to help you. So thank you so much the construct teams which have made this such kind of PDF and making like they created this PDF to
Mm-hmm.
so the essential like cd command, cd command, as well as the s command and the LA. So the commands I have learned in
Mm-hmm.
this. So
Mm-hmm.
if you want to uh, create some directory, so mkdir is one of the command, and touch command is one of the command if you want to build any kind of file inside the directory or your folder. Yeah. So visualize VI command is also there to edit the codes in the terminal only. So if you want to edit something in terminals, so using this VI commands, you can edit that. Yeah.
Mm-hmm. All right. All right.
Then
Okay, go ahead. You've got about
these are the
15
like
minutes, so yeah, let's go.
yes, so advanced permissions like which you have created, the file you have created. So you have to give the permission for running, read, write, and execute the command. So chmod, one of the command that is very good command. Chmod 777 like 4421. Like these are the numbers. If you chmod 777, so you can give the permissions for read, write, and execute the file.
Mm-hmm.
Then this htop what is running in your system and you can use that command to visualize that process. Yeah, so these are the development environment what I have used to build such kind of basis script. Then like what is the getter function, setter functions, how to use that, read if you want to get any data from the sensor, so you can read any. robot data from the getter and setter functions, which we have used in our base script also. Then control logic reads and what are the uh, eight cases which we have made in the obstacle avoidance basis script. So using these logic, we have created that. First, it will use the it will take the data from the get function. Then we have to set or we have to give some values like threshold value which we have set. So these are the control logic which we have made. So obstacle so for logic we have used. So I have tested these basic script in gazebo simulations environment and as well as the real world also I have used. So challenge what I faced like if else conditions what I have applied it was very that time it's looking very difficult for me. Now it's become very easy because of this learning modules which I have provided. So managing multiple terminals. So and the time which was sometimes negative. So negative will not will work in this obstacle avoidance. So how you can avoid to be negative so that also logic that also we have used. So this was the challenge I faced during this. Then learning outcomes, what I got, like now I understand the Linux and the fundamentals behind it, and the what is base script, how you can make directories using Linux, and some robot control how you can controls and the real world robot workflows are now I understand. So in my coming presentations futures definitely I am eager to learn these roles also because this was the basic things to understand the roles like Linux is the basic things you have to be going through. It is a must learning procedure. So what was the conclusion is like I successfully applied the Linux in robotics and now I am ready to advance roles development like roles development.
Mm.
So
Okay.
thank you so much the construct team for such a kind of opportunity which you have given to me. Yes, sir.
Okay. All right. Thank you very much, Sachin. So, what I wanted us to do is, in fact, let's do it now. So, let's go back to the IDE, right, and then have a look at your obstacle avoidance script, right. So, there are some issues that we wanna.
Uh, this one, sir.
Yes. Yeah.
Yes.
All right. So, can you explain to me a bit more how many test cases you were using, right? So, for your robot when it's navigating, how many test cases is it checking? So are you considering 5 indexes, 3 indexes, more than 5? What's going on? How do you make it perceive obstacles and how do you make it avoid obstacles? So I want an explanation on that.
Yes, sir. So total eight different cases we have used.
Mm-hmm.
Okay. So like front, left, and uh, like there is a eight cases which I made. So front is not free, front is not free, front right is not free. Then what robot have to do? So turning left or right, we have to. So this is one of the case,
Mm-hmm. Okay. So in each case, right?
and
How do you? All
yeah,
right. All right. So in each case, how do you determine how far your robot goes? Right? Can you explain that a little bit?
yes. So how far like for angular or for linear velocity, sir? You are asking.
For linear velocity. So let's say you found a
Yeah.
zone that's clear to go forward. How do you regulate the distance your robot covers?
Yes. What I did. Uh, yes. So I have set this linear velocity is 0.2. Yeah.
Okay.
So for this is the velocity which a robot will use to move forward. Yeah, using this command. So here you can say,
Okay, so it just moves what? How is move time calculated?
yeah, like move time is like time is equal to distance. Per second. Distance equal to like this is the basic formula like distance upon time. Yeah. So using that, I have calculating the moving time. Yeah.
Yes, so what I want you to explain to me is how do you find that time, right? So obviously you're using some type of sensor data to calculate that, but I want you to explain in more
Yes, sir.
detail how is the distance acquired in the first place, and then how do you calculate how far it moves, right? So,
Yeah. So sensor data, this front range is this sensor data what I am getting. Okay, so this data I'm getting, these are the like this dollar sign is the value what I'm getting. Okay, so minus threshold value
okay,
divided by yeah divided by zero point 0.1 I did. So these are the time what I'm getting.
okay, why divide by point 0.1?
So uh, like for
Where's that value coming from? That's what I want to understand.
these zero point 0.1 like that value the value what I'm getting front range get this value I'm getting from here and minus threshold. So like based on the speed zero point 0.1 meter second we actually checking this.
But your speed is not
So
okay. But your speed is not your linear velocity is not being set to point 0.1. It's being set to point 0.2. So how is that
yeah
possible?
um, yeah why because recently I am running the robot, so it was not moving forward. Robot was not moving forward, so it was stopping, going and rotating in a loop. So I decided to increase the linear velocity.
So whenever you made that change, what happened to point 0.1? Did you forget to change the other values? What's going on here?
Yeah, sir. Because like point right now I changed this threshold value zero point 0.3. It was zero point 0.5 earlier, so might be it is it's motion. Yeah.
All right, all right. I understand your issue, Sachin. All right. So what we're gonna do is let's wrap it up here, and then we can finish our conversation on Zoom. All right.
Yes, sir.